Make it bigger. Okay, next slide will be on electric signal. Last week we learned on Thursday class, I did some demo on PPG signals. So today we want to explore on the electric signals. Okay, as recall from intro to human physiology topics in the first lecture, we learned that our body contains lots of cells, and cells of the body that carry electric signals are basically the nerve and the muscles. And you have all over your body nerve and muscles that carry electric signals. Okay, because of the presence of intracellular and extracellular ionic current movement. Okay, so the results of the current movement is actually producing electrochemical process. Okay, and I'm going to show you today's lecture will be a lot on using videos which helps understand how actually electric signals are occurring in our body. And then once you understand the nature of the electric signals from the body, you can obtain the signals using the appropriate systems. Okay, and in this figure, we have like the conduction pathway of a tube, whereby inside of the tube you have charges, negative charges in the inside, positive charges in the outside. And this is actually an extract of the nerve cell. So you take the conduction part of the nerve cell. So you will see inside will be negatively charged compared to the outside of the cell. Okay, so let's watch videos. Action potential, because that is the basics of electric signals propagation from our body. I'm going to turn on the volume. I hope there is no echo. Echo lah. Either side of the membrane are negatively charged proteins, negatively charged chloride, positively charged sodium. Video tak keluar suara.
Tak ada.
Sekejap. Dapat dengar tak?
Tak dengar.
Tak dengar.
Doktor.
Doktor. My problem is my PC cannot take my voice, so I'm using my phone as the microphone. Volume 1. I will put these videos on UKM Folio so that students can download. It's either you download or you watch from your UKM Folio without downloading lah. I have a series of videos actually. First, this video, maybe I will explain. Let me run the video first. It's only this one is a little bit long, 5 minutes. This is regarding the actual action potential, how an impulse or electric impulse begins or occur in our body. So it is the basic of understanding of electric signals from our body. So that's why it's important that you are introduced with the concept of action potential. Because for EECG signal, EEG signals, it's all about getting that action potentials within your body. But because of inside the body, it's a combination of lots of action potentials going on. So it will produce waveforms. So the one unit impulse is actually the action potential. So let me play the video. So without voice. So later on you can replay from UKM Folio. You can hear voice. But I haven't uploaded the video yet. So let me just play and pay attention through the images sajalah. Okay, so that is about the action potential, whereby an action potential is actually production of a nerve impulse or an electric impulse in a nerve cell. It can also happen in the muscle cells. Okay, it's simply an action potential is simply comprised of depolarization phase followed by repolarization. A nerve cell has a resting potential of about negative 70 millivolt. Okay, so when depolarized, and the process of production of an action potential is actually uh, follow all or none principle. Uh, all means that it will shoot a full uh, impulse only when the threshold is exceeded, and the threshold is negative 50 millivolts. If the excitations is above the negative millivolts, meaning that when the depolarization reach higher than negative 50 millivolts, you will produce an action potential. If it is not exceeding the negative 50 millivolts, you don't have any action potentials. So the signal simply dies off. But once it has exceed the threshold value, it produces one spike up to about 40 plus millivolts, upon which no more charges can flow in, or sodium flow in, and potassium starts to flow out. And that will produce repolarization. The word polarized uh, is because our resting membrane potential is always at negative 70 millivolts. So it has to come back to the resting potentials. That's why we call it repolarized. However, when the signals go down to repolarize, it will need to become a little bit over polarized. So it is said as overshoot. You have an overshoot. It will go beyond the negative 70 slightly. Maybe it goes about negative 70 or negative 90 millivolts. That is the hyperpolarization phase. And that in that phase, the nerve will not respond to any reaction. It is called latency period. And the influx and outflux of the charges can give inhibitory or excitatory effect. The excitatory effect, if I show you again the video, where is it? Because I can show you. Okay, this is when it is rising, it is the blue one is excitatory. Positive signals is excitatory. Negative signals lower than the resting potential is inhibitory. Inhibitory means negative signal. Excitatory means you excite it. You tend to produce depolarization. So these signals can sum up inhibitory and excitatory. Okay, so the action potential is actually graded potential, where you can have this part is the stimulus, and this part that rise above the threshold is the depolarization. From the maximum, it can be up to 30, 40 or 50, depends on individuals, and this phase is called repolarization, and overshoot is actually hyperpolarization, and then it comes back to the resting potential, and the resting potential is always at negative 70 millivolts, and the production is happening because of the gated channel, because the channels are actually a carrier for the charges in the body, and the action potential is actually how it moves from one portion to the next portion, because earlier part of the cell is having a repolarization, the next part to the right side will be having repolarized, so that the next part, so the signal will continue in one direction only. Okay, and okay, the conduction of the action potential in a nerve cell is always cell tertiary conduction, whereby cell tertiary means fast movement, fast because of jumping of the charges, because of the node, the charges only enter through the node of Ranvier, which is the opening of the nerve cell. This nerve cell is covered with the myelin shed. The name of the myelin shed is either it's a oligodendrocyte. This is the scientific names for the cells in the nerve tissues. In the central nervous system, it is called oligodendrocytes. In the peripheral nervous system, it is called the Schwann cell. But they are actually the same thing. It's just that depending on the locations, the name are different. These myelin sheds are actually insulating the axon. The axon is the part of the nerve that conducts the current. The myelin shed has two functions. One is to insulate or to avoid leakage of charges from the inside of the cell to the outside, and it also allow cell tertiary conductions, because only charges can only move from point to the point, so that it can jump. If there is no myelin, the charges has to move part by part throughout the nerve, so it becomes a very slow movement. So with the presence of the myelin shed, it can facilitate the action potential conduction, or the impulse propagation. Okay, but at the junction at the end of the nerve, where you have neurotransmitters, you have axon bulbs here, there will be chemical process. This will be the connecting axon terminal, and this is the presynaptic neuron, and this will be the postsynaptics. Presynaptic means prior to the synapse, and this airspace between one neuron to the next neuron is called the synapse. Synapse. So there will be jumping of signals from this presynapse to the postsynapse, so that the electric signals can be propagated from one neuron to the next neuron. Okay, and for the conduction of transmission signal from one neuron to the next, it requires calcium ions into the scenery. Whereas for action potential, you only need sodium ions and potassium ions in order to produce the action potentials. So here, so that is the basic of production of an action potentials. Then the next, I want to show you the next video. Again here, no voice. I let you watch first, then I explain. Sorry.
Doctor.
Not this one. We are going to
Doctor.
go with the ECG first. I come back to my lecture note. Okay, now we move on to the objective of today's lecture is observing electric signals from the body. So we have few kinds of electric signals. We have the EEG signals, ECG signals, EMG signals, and other electric derived signals such as the galvanic skin resistance signals and also the electrooculogram signals. So the nerve signals, the EEG signals is obtained from the brain. The electroencephalogram is actually measurement of the many collections of action potentials underneath your skull. Okay, and actually to record an electric signal from the body, you need electrodes. So in this diagram, it shows a basic biopotential measurement. Electric signals from the body is always referred as biopotential signals. Potentials from your electric signals, you know that when there is a potential difference between 2 points, you can actually measure the signal difference. So the basics of measurement of electric signals from the body is always differential measurement, whereby you need to have at least 2 electrodes, but for safety reasons, we always have 3 electrodes placement, be it EEG recording, be it ECG recording, any kind of electric measurement, at least 3 electrodes. The ECG signals that you measure, you will see many electrodes because you place at one time all electrodes, but each signal is actually displaying signals from 3 electrodes at a time. Okay, same thing with your when you have your EEG recording, you will see the doctor put like 10 20 electrodes on the scalp. Although there are 20 electrodes at one time for each signals, it is actually the recording of from 3 points. One channel is always the ground. The other 2 channels is positioning from 2 points on the surface of the body. And because it is differential measurement, you always subtract one signal from another. Then you will have the biopotential. And between the 2 electrodes, you will have to have an amplifier to amplify the 2 signals. The small difference, we will not see, we will not feel the difference between 2 points in our body. But with the presence of electronics technology, with amplifier, with instrumentation amplifier, we can measure, we can extract very small biopotential signals from the surface of the body. Okay, so From these many electric signals, we will look at the ECG signal first. Okay, so let's watch this ECG signal. Everybody is familiar. It is even from my first lecture I've mentioned for the cardiovascular system to learn about the heart condition. The ECG signal is the appropriate signal for us to look at. So for the ECG signal, it is actually for each signals, you need to at least know who is the father. ECG signals has been established by William Enthovens. He has discovered that our body, the heart, can generate electric signals as early as 120 years ago in the early 1900s. And ECG is the most established electric signals. PPG signals, as I mentioned, as I showed last week, is from only recently being clinically accepted, although the PPG signal has been discovered by Hertzman. Remember, in the 1939s, if I'm not mistaken, in the 1930s, one scientist observed photoelectric, but nothing much done to the photoelectric signals until the late 1990s. The group of scientists from Japan has proven that using the photoelectric signals, we can use the signals to measure oxygen saturation from the blood. Since then, PPG signals has been used tremendously, and for the ECG signals, Enthoven is the father of the signals. So let's watch some more videos regarding the ECG signals. Okay, the first video is showing mechanical. There's nothing much about electrical activity in this video. It's just showing the mechanical part of the heart, where here you will see the heart when it's pumping. The top part of the heart, the atria, pumps together, followed by the bottom part of the heart. So in this video, it's simply showing 4 valves of the heart. Okay. Okay. This is simply mechanical movement of the heart tissues. In order to, you will see from the right side is blood circulation from the rest of the body collected at the atria, but in the left side, the circulation from the pulmonary. So between the compartments of the heart, there will be 4 valves. First valve, and so on. So you can watch later for the mechanical part. And I want to show the electric part of the heart, where we have, okay, the heart has its own rhythmic pattern. The origin of the impulse, where we have SA notes and the AV notes. Okay, if I show you from the beginning, okay, there are 2 points in the heart tissues, which is the location called SA node on top of the right atria, and another location between the right atria and the right ventricle. There will be another node. It is called node because that part of the cells of the heart is able to produce impulse, to generate, it initiates the action potential. The heart is a built-in mechanical pump where in order for the muscles to contract, it must receive electric signals, and that electric signal is actually starting from the SA nodes. So these SA nodes, it generates its own rhythm. Every 1 second, it will initiate one action potential. Okay, so if you see here, the SA node is actually sinoatrial. So the signal from sinoatrial propagates to the AV node. AV stands for atrioventricular because it is located between the atrial and ventricles. And these signals then propagates through the fibers in the AV bundle. From the AV bundle, it will branch towards the end of the nerves, and these are actually the nerves. The end of the AV bundle will be the Purkinje fibers, or this upon which, when the Purkinje fibers receives the action potential signals, it will cause the ventricles, which is the lower part of the heart, to contract. The transmission of the action potential signals from the SA nodes to the AV nodes will cause the atria, or the top part of the heart, to contract. So if you watch again, the signals from SA nodes reach the AV node, it will be delayed a little bit,